April 28, 1945. The East China Sea, about 20 miles southeast of a Japanese convoy. Lieutenant Commander James Patterson sat inside his PB-4Y-2 privateer at 15,000 feet, focused on the mission. In front of him, the radar operator tracked 4 small blips moving across the screen. Those dots represented Japanese ships his crew would never actually see with their eyes. Inside the bomb bay, 2 ASM-N-2 Bat missiles waited to be released. These were no ordinary bombs. They were so advanced that the Japanese Navy, even after being hit multiple times, still had no idea what kind of weapon was striking them. "Target bearing 045, range 18 miles, the radar operator called out. That was the only description given for real ships with real crews, reduced now to glowing shapes on a screen. Patterson's role was simple: release the weapons and let them guide themselves. Once the missiles were gone, his crew would turn back toward home, leaving the machines to finish the job before the enemy even knew what was happening. This moment showed how warfare had changed forever. Victory was no longer about bravery or flying skill, but about America's ability to mass-produce weapons that could think for themselves. The Bat missile was the very first fully automated guided weapon ever used in combat. It marked the beginning of modern automated warfare, a direct ancestor of the smart bombs and drone strikes used today. The ASM-N-2 Bat was designed by the National Bureau of Standards, under the leadership of Dr. Hugh Dryden, who would later serve as NASA's first deputy director. Unlike the German radio-controlled glide bombs, which required constant guidance from an operator, the Bat was truly fire and forget. Once launched, it used its own radar to locate and hit its target without further human control. For 1945, its technical capabilities were groundbreaking. The missile weighed 1,180 pounds, stretched 10 feet across its wings, and carried a 1,000-pound AN-M65 warhead. Its S-band radar seeker could detect large ships from as far as 20 miles in clear weather. Inside, analog circuits, vacuum tubes, and servo motors continuously adjusted the control surfaces, keeping it locked on target until impact. Work on the project had started back in January 1942, when the Navy's Bureau of Ordnance realized the need for a standoff weapon that could strike enemy ships from beyond the reach of anti-aircraft fire. The Bureau turned to the National Bureau of Standards, which pulled together aerodynamic experts, electronics engineers from Bell Labs, and physicists from universities across the country. By March 1943, prototypes were already being tested at Naval Air Station Patuxent River. What made the Bat so remarkable wasn't just its design, but America's ability to build it in numbers. Germany could only produce small batches of guided weapons by hand. The U.S., however, mass-produced about 3,000 Bat missiles, though only around 420 were actually deployed in combat before the war ended. The total program cost was $12 million, about $180 million in today's dollars. Yet that was less than 0.1% of U.S. military spending at the time. The Bat's first combat test came on April 23, 1945, when Patrol Bombing Squadron 109, VPB-109, attacked Japanese ships in Balikpapan Harbor, Borneo. Both missiles malfunctioned, showing that even revolutionary weapons had problems. But within days, success followed. On April 28, 1945, VPB-109 scored the Bat's first confirmed kill by sinking a Japanese patrol vessel in Balikpapan Harbor. The missile traveled roughly 9 miles from release to target, striking while the aircraft was already on its way home. For the Japanese sailors, the experience was terrifying. They never saw the attacker, heard an engine, or had any warning. Death seemed to fall silently from nowhere. The psychological effect was even greater than the physical damage. Japanese crews had been trained for direct combat, ship-to-ship battles, or defense against attacking aircraft. The idea of a weapon that could guide itself was beyond their imagination. The Bat highlighted the massive technological gap between the United States and Japan by 1945. Japan entered the war with excellent torpedoes, skilled sailors, and powerful night-fighting tactics. Their Type 93 Long Lance torpedo was the best in the world, with longer range than any American equivalent. But while Japan focused on refining proven weapons, the U.S. was inventing entirely new ones. The Bat combined miniaturized radar, gyroscopic stabilization, analog computers, and automatic control systems. Japan not only lacked these technologies but also struggled to even understand them. When Japanese engineers examined captured American radar, They could recognize parts, but they couldn't comprehend how the systems worked together. The difference wasn't just in technology, it was in industrial methods. American factories specialized in standardized mass production. Every Bat missile used interchangeable parts built to exact specifications. Japanese factories still relied on skilled craftsmen making components by hand. That meant the U.S. could produce thousands of advanced weapons faster than Japan could produce basic bombs. In combat, the Bat achieved limited but meaningful results. On May 1, 1945, VPB-109 sank another small Japanese vessel near Borneo, though the exact type was not identified. On May 28, the squadron used the Bat against the escort ship Kaiboka Naguni near Okinawa. The missile struck the ship, causing heavy damage, though it didn't sink. Aguni limped back to port but never returned to service. On June 18, 1945, VPB-109 scored its final confirmed kill by sinking another Japanese patrol vessel. The squadron also destroyed an oil storage tank on land, proving the weapon could hit stationary ground targets as well. Altogether, VPB-109 confirmed 3 sinkings with the Bat, all smaller ships. While modest compared to traditional bombing campaigns, these missions proved a critical point. Machines could now take over the act of targeting and killing. Other squadrons equipped with the Bat, including VPB-123 and VPB-124, were less successful. Their reports described issues such as radar seekers being confused by coastlines, tropical humidity damaging electronics, and difficulties locking onto targets in busy waters. Sometimes crews simply jettisoned the missiles rather than risk flying home with live weapons still on board. Even with these setbacks, the Bat's combat record marked the first real step into automated warfare. Its results showed the world that once released, a weapon could think, search, and strike on its own. It was a small beginning, but it pointed directly toward the future. Smart weapons, precision strikes, and a battlefield increasingly shaped by machines. After the war, the Joint Army-Navy Assessment Committee reviewed the record of the Bat missile. Their conclusion was clear. In real combat, its performance was average at best. Tests against single ships in open water had looked promising, but in the real world, things were different. Islands, bad weather, and the limits of 1940s electronics all reduced accuracy. Even so, the Japanese Navy found the weapon terrifying. They had no countermeasures, no idea what was hitting them, and no defense to use. Crews reported being struck without warning by something they could not see or hear. The fear created by the Bat often mattered more than the damage it caused. The program highlighted the deep contrast between how the United States and Japan fought the war. America could invest millions in a weapon that only sank 3 small ships because the research itself advanced technology for the future. Japan, by comparison, had no way to even imagine such weapons, let alone develop or stop them. American engineers were able to constantly improve the design. When early models had trouble with humidity-damaging electronics, new sealing methods were added. When the radar confused coastlines with ships, adjustments to the system made targeting more reliable. Each flaw found during use was quickly fixed and built into new production runs. Japan, on the other hand, was struggling to maintain even basic operations by 1945. Fuel was so short that ships often remained in port. Ammunition quality dropped as raw materials ran out. The few radar sets they had often failed with no spare parts to replace them. The problem wasn't just technology, it was the lack of an industrial base to keep pace. The Bat program was driven by thousands of American scientists and engineers who treated warfare as an engineering problem. Dr. Hugh Dryden, who directed the project at the National Bureau of Standards, approached it from the perspective of aerodynamics and control systems, not battlefield tactics. His team included experts in areas that barely existed before the war: servo mechanisms, analog computing, and radar engineering. In Japan, naval officers who had been trained for traditional warfare suddenly faced weapons that made their skills meaningless. Generations of training in courage, close combat, and naval tactics did not matter against bombs that could guide themselves from beyond sight. The military culture, rooted in the samurai ideal, had no answer to the industrial war America brought to the Pacific. For Japanese sailors, the Bat created a special kind of fear. Dying in a visible fight was one thing. Being destroyed by an invisible machine was another. Survivors often described helplessness and confusion, as if they were facing something outside normal warfare. While America pushed technology toward removing the pilot from danger, Japan moved the opposite way. Their answer to the Bat was the kamikaze, turning pilots into human-guided missiles. Vice Admiral Takejiro Onishi openly stated the goal. If Japan could not match American science, it would rely on warriors willing to die. These two paths, mechanical precision versus human sacrifice, defined the final stage of the Pacific War. For American sailors under kamikaze attack, the feeling was much like what Japanese crews felt under Bat attack. Death arrived too quickly to stop, from attackers that could not be deterred. But while the Bat was a step into the future of warfare, kamikaze strikes were the last stand of a military tradition collapsing under modern industry. The Bat also fit into a wider U.S. campaign to cut Japan's supply lines. Operation Starvation, carried out by B-29 bombers dropping magnetic and acoustic mines, had nearly shut down coastal shipping by April 1945. Submarines had destroyed most long-range merchant ships. The Bat added yet another layer to this strategy. Even though it directly sank only 3 ships, the fear it created spread across the fleet. Japanese captains hesitated to sail even in areas where no Bat squadrons were present. U.S. intelligence made sure that fear grew. Documents were deliberately left for capture. Broadcasts described thinking bombs, and survivors of attacks were allowed to return to spread the story. The Bat was both a weapon and a tool of psychological warfare. Still, the missile's limits were real. Its analog guidance system relied on vacuum tubes that could fail, servo motors that required exact calibration, and radar that was easily confused. For best results, conditions had to be nearly perfect. Clear skies, isolated targets, and working electronics. Out of about 100 missiles launched in combat, only a handful hit their targets. The Bat worked best against slow or stationary ships in open water, but had far less success near coasts or in bad weather. Even so, the weapon proved the idea was possible. Every guided missile that came later built on what the Bat revealed: the need for better radar targeting, more reliable electronics, and improved control systems. It was less a finished weapon than a first step toward automated warfare. The last use of the Bat came on August 13, 1945, just 2 days before Japan surrendered. VPB-109 launched 2 missiles at what they believed were Japanese ships. Both missed. It was a fitting conclusion for a weapon that often failed in combat, but pointed directly toward the future. By the end of the war, about 420 Bat missiles had been deployed to the Pacific, with only about 100 fired in action. The rest were returned to the U.S., where tests continued until 1948. These trials were disappointing, and by the early 1950s the Navy removed the Bat from service. Even as a failed weapon system, the Bat's legacy was immense. It proved automated targeting was possible, and it laid the groundwork for the weapons that followed. From the Sidewinder to the Tomahawk, every U.S. guided missile carried lessons first learned from the Bat. Many of the engineers who worked on the Bat missile later became key figures in Cold War weapons development. Dr. William McLean, who had helped design the Bat's guidance system, went on to create the Sidewinder air-to-air missile, one of the most successful weapons of its kind. The Bat provided the foundation for technologies that would dominate the next era of warfare. Military historians still debate the Bat's true significance. On the surface, its record looks unimpressive. It sank only 3 small ships despite a $12 million investment and years of effort. Critics argue that traditional torpedo bombers or dive bombers could destroy more ships in a single mission than the Bat program achieved in total. But that view misses the point. The Bat wasn't about immediate results, it was about proving what was possible. It showed that guided weapons could work, that machines could operate independently in combat, and that the future of war would rely less on human instinct and more on sensors and computers. The Bat was the first step toward the precision-guided weapons that shaped conflicts in Vietnam, the Gulf War, and beyond. The Bat also reflected America's unique industrial philosophy, the willingness to spend heavily on new technology even when short-term results were uncertain. Japan, fighting to maintain basic capabilities, could not imagine taking such risks. America invested in ideas that might not pay off immediately, but would define future battles. Japanese naval records from 1945 reveal just how confusing the Bat was to those who faced it. Some reports described guided torpedoes. Others thought it was a type of robot aircraft. A few even speculated about death rays. Without understanding the threat, they had no chance of creating effective countermeasures. Post-war interviews with Japanese officers highlighted the psychological shock. They could accept being outnumbered or outgunned, but the idea of being killed by a machine that guided itself shattered their basic beliefs about combat. Several described it as facing not just superior technology, but a completely new definition of war. Japan's own technical bureau tried to analyze what was happening, but with no captured examples and little knowledge of the science behind the weapon, their efforts went nowhere. Suggestions for countermeasures ranged from smoke screens to confuse radar, to desperate plans involving suicide swimmers intercepting missiles. None were ever carried out before the war ended. The Bat's design lives on in modern weapons. Fire and forget engagement, autonomous target selection, and standoff attack were all born with this missile. Today's anti-ship missiles, like the Harpoon and Exocet, follow the same core principles, only with better electronics and more reliable guidance. The Bat also raised ethical issues that remain unresolved. For the first time, a weapon killed without human input after launch. It shifted lethal decision-making from people to machines. Questions about responsibility, morality, and the nature of war itself first appeared here, and continue today in debates about drones and autonomous weapons. For the U.S. Navy, the Bat was also a learning experience. Engineers discovered the importance of building reliable electronics, refining radar discrimination, and keeping systems simple enough for combat use. These lessons shaped every guided missile that followed, saving both time and money in future programs. The program's numbers tell the story of both its limits and its importance. Total produced about 3,000 units. Deployed operationally, 420 units fired in combat, about 100 units. Confirmed sinkings, 3 small vessels, ships damaged, 1. The escort vessel Aguni program cost $12 million in 1945 development time, 36 months from concept to combat. By the numbers, the Bat did little, but strategically it opened the door to precision warfare. The ASM-N-2 Bat was the first truly autonomous weapon used in battle. Its record of 3 ships sunk may look minor, but its historical role was massive. Every smart weapon, from guided bombs to cruise missiles, traces its origin back to this radar-guided glide bomb of 1945. For the Japanese sailors who faced it, the Bat was unlike anything they had ever seen. They died without spotting the attacker, struck by weapons that could see in darkness and steer themselves. They were the first in history to fight against machines that acted on their own. Their shock and terror marked humanity's entry into the age of automated war. The Bat did not decide the outcome of the Pacific War. That victory came from overwhelming American production, superior logistics, and ultimately the atomic bomb. But the Bat revealed what the future would look like. Precision instead of mass, automation instead of courage, technology instead of warrior spirit. Every guided missile, every armed drone, every smart bomb owes its lineage to those first radar-guided weapons launched over the Pacific. And with them came questions that still haunt military thinkers today. When a machine makes the decision to kill, who is responsible? How do soldiers find meaning when their skills no longer matter? What happens to war when killing becomes automatic and impersonal? These questions were first posed by a 1,180-pound missile filled with vacuum tubes and servos. The Bat may have had only limited success in combat, but it opened a door that can never be closed. It carried more than explosives. It carried the end of one age of warfare and the beginning of another. The Japanese sailors who died without seeing their attacker were the first victims of automated war. Their helplessness foreshadowed the experience of soldiers worldwide who would later face precision-guided weapons. They learned in the harshest way possible that the wars of the future would belong not to the bravest warriors, but to the smartest machines. The Bat missile entered history as a weapon almost forgotten, yet perhaps one of the most important of World War II. It achieved little on the battlefield, but its impact on the future of warfare is still with us today.